In this video, we're going to be looking at how to create the graphs of tangent and cotangent, and then we're going to be looking at some key features of those graphs. All right, let's start off with tangent. So we remember that our ratio for tangent is sine over cosine, and we're going to use this as we move our way around the unit circle, and we're going to graph those quadrantal angles down here. Okay, so let's start with 0 right here. So sine over cosine. Sine goes with the y-coordinate and cosine goes with the x-coordinate. So if I do sine over cosine, 0 over 1 equals 0. So I'm going to start with a point on the origin. Now I'm going to move here to pi over 2, sine over cosine, y over x. Okay, so now I've got 0 in the denominator. When you have 0 in the denominator and it doesn't cancel out, that's going to give you an asymptote because the graph is undefined at that point. If you don't remember that word, go ahead and write it down on your paper. Asymptote is what that graphical feature is, that dotted line that we're going to get very close to but never touch. Okay, let's continue around here to pi. Sine over cosine, 0 over -1. 0 divided by anything other than 0 is 0. So I've got a point right there. I'm making my way around to 3 pi over 2. Now I'm going to have -1 over 0. So again, that's going to give me an asymptote because it is undefined at that point and nothing divides away. All right, and then we're going to finish up right here at 2 pi. At 2 pi, sine over cosine, 0 over +1 again, and we're back to 0. Okay, so let's see what happens on the negative side. Let me get some space up here for us. All right, on the negative side, that just means we're going to go around the circle in the opposite direction. Okay, so let's start here at 0, and we've already got our point. So we're going to move around to negative pi over 2. That puts us here. Sine over cosine, -1 over 0. All right, anything divided by 0 other than 0 itself is undefined. When it's undefined, I'm going to have that asymptote because nothing cancels out. All right, moving my way around to pi, negative pi going this way. So sine over cosine, 0 over -1. Well, that's going to be 0. 0 divided by anything other than 0. Moving my way around here, -3 pi over 2. Well, that's going to be +1 over 0. So let me just erase my negative there. +1 over 0, undefined. So when it's undefined and nothing cancels out, what do we have at -3 pi over 2? We have an asymptote. So let me dot in that asymptote. The graph is going to get very close to this line, but never touch it. All right, and then I'm going to go around back here to -2 pi, all the way around the circle. And so I'm just going to erase this negative right here, 0 over +1, back to 0. Okay, well that doesn't really give us a whole lot to go on. I've got some points, but I can't connect them because I cannot cross over my asymptotes. I can get very close to them, but I can't cross over them. So we have to remember the signs for tangent. I remember that tangent is positive in the first quadrant, and tangent is also positive in the third quadrant, right? All students take calculus, so positive in the first and the third. So if I were to unfold the unit circle, the first quadrant is right here. And in the first quadrant, it's supposed to be positive, and it's also supposed to be approaching but never crossing this asymptote. So the only way to do that is to go up. My positive values are above the x-axis. So there's my positive values. This really should start at 0. It's kind of hard to aim on the screen. Not have the part that goes below the x-axis right there. So there we go. Okay, and then when I move into the second quadrant, unfolding that circle, in the second quadrant, tangent is negative. So again, I'm approaching but never crossing this asymptote, but I'm going to be negative, which means I'm going to be below the x-axis. Then in the third quadrant here, I'm going to be back to positive. And then in the fourth quadrant, which is here, I'm back to negative. And when we move around the circle the opposite direction, we do the same thing, just in the backwards order. So you can see that as I move negative, I go first into the fourth quadrant, which is going to be negative, and then the third quadrant, which is positive, the second quadrant, which is negative, and end up in the first quadrant, which is positive. So there is my graph of tangent theta. Again, it's really hard to aim on the screen. My points should be actually on the axis, not directly below it. So here's a better picture. I got Desmos to draw this one for me so that we can look at it a little bit easier. And you can see that it is actually crossing the x-axis at all of the pi's, the integer values of pi. And then my asymptotes here are at all the pi over 2's. And the whole ones or the negative ones here is where it's going to cross the axis. So domain. Domain is all the possible values of x. And remember, this is cyclical. It's a periodic graph. It goes on and on forever in both directions. So the domain is going to be all real numbers except where I have those asymptotes. And remember, we said the asymptotes are at the pi over 2. So I'm going to have n pi over 2, where n is an odd integer. All right, and it has to be an odd integer because if it was an even integer, like say 4 pi over 2, 2 goes into 4 2 times, and so I'm going to end up with this point right here. So n is every odd integer, both positive and negative. All right, how about range? Well, remember our technology is a little bit limited. We ought to have arrows on the ends of all of these, both going up and going down. So when we get ready to write our range, you can see that it goes on and on forever down, and then it goes up without jumps, without skips, on and on forever up. So our range is going to be negative infinity to positive infinity. All right, how about the intercepts? Well, you guys can see that it's going to cross the x-axis an infinite number of times, and it's going to cross the x-axis at those integer values of pi. So x-intercepts occur every n pi when n is an integer. And this time it doesn't matter whether it is positive or negative. It doesn't matter whether it's odd or even, right? 2 pi would be an even integer times pi. 1 pi is an odd integer. Over here I've got some negative integers. 0 is an integer. So every integer value, n pi, is where it's going to cross the x-axis. All right, y-integers. You're only allowed, y-intercept. You're only allowed one y-intercept. And here it is right here. My y-intercept is at the point 0, 0. All right, the last thing we need to look at is the period. So you can see that the period is the amount of space it takes to make one complete rotation. And this rotation starts at negative pi over 2, and it ends right here at positive pi over 2, right? And you can just see that it makes that same shape over and over again on both sides. So the distance, 1/2 pi to the left and 1/2 pi to the right, put those together, and the period is 1 whole pi. And it's positive because it's a distance. All right, let's look at cotangent. You remember that the ratio for cotangent is cosine over sine. So we're going to do the same thing. We're going to go around the unit circle, cosine over sine, and we are going to put the values in for theta. So when I get to 0, cosine over sine is going to be 1 over 0. All right, so that's undefined. That's going to give me that asymptote. Moving around to pi over 2, cosine over sine, 0 over 1 is going to give me a point on the axis. All right, moving to pi. So that just means I need to add a negative right there. Cosine over sine, negative 1 over 0, but that's still undefined. Still going to give me an asymptote. All right, 3 pi over 2, 0 over negative 1. Same thing, I just need to add my negative. Still going to be 0. And then making my way back to 2 pi, cosine over sine, 1 over 0 is undefined. So I'm going to have an asymptote. The same thing is going to happen as I move around the unit circle backwards. So at negative pi over 2, I'm going to be at 0. Right here at negative pi, it's going to be undefined. Negative 3 pi over 2, back to 0. And then at negative 2 pi, again, it's undefined. And we're going to have to use the same sort of logic we used with tangent, where in the first quadrant it's positive, and in the second quadrant it's negative. But look, to get to the asymptote, I have to go the opposite direction. Instead of going up and to the right like I did before, I'm going to go up and to the left. And then here in the second quadrant, it's going to be negative, positive in the third quadrant, negative in the fourth. Okay, let's go around the unit circle backwards. In the fourth quadrant, it's negative. Third quadrant, it's positive. Second quadrant, it's negative. Around to the first quadrant where it's positive. So you can see a very similar shape to cotangent and tangent. It's just that cotangent is shifted to the side, pi over 2, and also it is a reflection. It goes the opposite direction. Okay, so here's my Desmos graph of cotangent. Let's look at domain. So this time, my asymptotes are on the integer values of pi. So my range is going to be all the real numbers except n pi, where n is an integer. So exactly the opposite of what we had before. The range, again, my technology, remember, is a little bit limited. I can't put those arrows on there. But my range is going to be all real numbers, negative infinity to positive infinity, because it's going down and up. All right, how about x-intercepts? So if you notice, the x-intercepts now are at the pi over 2's, which is the opposite of what we had for tangent. So when we do the x-intercepts here, the x-intercepts are going to be at n pi over 2, where n is an odd integer. The same sort of thing we had for the range the domain when we did tangent, because they're shifted from one another. The y-intercept, all right, well, that's on the y-axis. But look, on the y-axis for this one, we have an asymptote. So we're not just going to leave it blank. We're going to write none, because there is not a place where it crosses the y-axis. All right, how about period? How long does it take to make one complete rotation? All right, just like tangent, you can see that it's this same red shape over and over again forever, both to the left and to the right. One of them starts right here at 0, and it completes right here at pi. So the distance of that one complete rotation, distance of one cycle, is pi. And so the period of this graph, just like tangent, the period for cotangent is going to be pi as well.